Oh, let's go ahead and we'll get started. Last week we talked about how to put together a solar system. And we took a look at our solar system and we found that uh, it's
Hmm?
always, obviously they're all that all the pictures are all the same. It's their depiction that changes. And probably the one on top is possibly, as far as scale is concerned, as far as the size of the planets, is probably the closest one. So we have four little planets and four big planets. And in between, we have two belts of junk. Uh, so what we're going to be doing is we're going to be going through uh, the solar system, essentially planet by planet, or two planets at a time. If one of the better pictures of our solar system that I like is, whoops, I have to get myself back on. There is this one. And as you can see, again, there is no scale to this whatsoever, but it does show the inner planets, the outer planets, the terrestrial planets, the Jovian planet. I mean, it gives all of the various names of this. And what we're going to be doing, the rocky planets are inside the asteroid belt. Beyond the asteroid belt, we have the gas giants. So tonight, what we're going to be doing is talking about Mercury and Venus, and taking a close look, or at least a human look, at these two planets. The thing is that really isn't enough time to get into detail about it, but what would it be like if you actually tried to live on these planets? So we're going to be taking a look at the inner planets, that's sometimes called the terrestrial planets, or the rocky planets, and that consists of Mercury, Venus, Earth, and Mars. And this is actually to scale. You can see that Earth is the largest of them. Mercury has the largest iron core. As a result, Mercury is actually the densest planet. Venus is very close to the size of the Earth, while Mars is probably, if the Earth is 5 as far as density, Mars is about 3. So as you get further and further away, there's less rocky stuff. There's more gaseous and icy stuff. And that's why as you move out, you get less and less dense. Now, there is a very, very false conception about how the planets orbit the sun. We look at the planets orbiting the sun and we think of them as concentric circles. Actually, this is false. The planets do not go around the sun in a circular path. They actually go around the sun in an elliptical path. So as a result, as you can see, there are times when Mercury is closer to the sun than at other times, and the same is true with Earth. And Mars really shows this difference. So if we were to, you know, estimate what was going on, we would say that the planets are actually going around our star in an elliptical path. And as it does that, the laws of Kepler do apply. When it gets close, it speeds up. And when it goes further away, it slows down. So it speeds up when it's close and then slows down. This is actually Kepler's second law. Now, the Earth does exactly the same thing. There are times when we are closer to the sun than at other times. And this is equal to about 2 million miles. So, so when we're closer to the sun, we do move faster around the sun. And obviously, when we are further away, we move a little slower. What this translates to is the fact that there are actually less days between the autumnal equinox and the vernal equinox than there is between the vernal equinox and the autumnal equinox. There's about a day difference. So there is another difference too. Well, actually, we are closer. What's interesting is that we're closer to the sun in January than we are in July, which doesn't seem to make any sense at all. But I assure you that it's due to the tilt of the Earth that forms our seasons, and in this case, not so much our proximity to the sun. So if we were to take a look at the sun between the time that we are furthest away and the time that we are closest, you can see that there is a very slight difference between the sun, or when we're looking at the sun when we're closest and when we are far away. So since the orbits of the planets do follow Kepler's laws, the people who kind of keep track of these things, the mathematicians who seem to have nothing else to do except sit in closets and play with their mathematics, they have Mercury going around the sun at its prescribed orbit, and it's really, at this point, using Kepler's laws, it's pretty simple to figure out where Mercury is going to be at any given time. The trouble is that when they actually did this and tried to find Mercury in the sky, it didn't work. Mercury's orbit, even though it does follow, for the most part, Kepler's laws, actually did something weird. As it moved around the sun, the whole orbit precesses. And as a result, there's not a very good way of trying to figure out where Mercury is going to be. Well, the mathematician said there has to be another planet out there that's between Mercury and the sun that's pulling on Mercury and causing the orbit to drift. And you'll never guess what they called it. They called it Vulcan, which brings up all sorts of things to mind. No, this was not the place where Mr. Spock came from. Yes, live long and prosper. This was actually the name of the planet that was supposed to be pulling on Mercury, causing the planet's orbit to precess. The reason why they called it Vulcan was because Vulcan was one of the gods of the sun. Well, there was a mathematician who lived at that time. He kind of came up with a theory that kind of explained what Mercury was doing. His name was Albert Einstein. And he said, well, space-time is affected by matter. And when matter moves quickly, it could affect space-time. And space-time is actually increases when you have a mass, and the distance actually decreases. And so he brought this up, and he was just hoping, when they started looking for Vulcan, he was hoping upon hope that they wouldn't find it. Because if they found it, all his theories go out the window. And what they found was the fact that, okay, we have Newtonian gravity, which is what they what they teach in schools. Um, and as the Earth goes around the sun, as it gets closer, it slows down. The planet speeds up. It results in time slowing and the length decreasing, and that actually changes the orbit of Mercury. So as a result, the orbit of Mercury precesses, and we have relativity actually changing the orbit of Mercury. So that was one of Einstein's first really good uh, accomplishments. Well, we've sent some probes to Mercury. We've sent Mariner, the Mariner series. And the neat thing about Mariner was the fact that this was in 1972, I believe. And Mariner was Act 73. And Mariner was the first one to use gravitational assist to be able to move the probe where we wanted it. So we pushed it toward Venus, and then the gravitational field of Venus actually turned it into the center of our solar system so that it would pass Mercury. And it was really a neat trick. And as a result, we got some neat pictures of Mercury. And this was the first time Mercury was seen. And the first thing we see are lots and lots of craters. And the best reason they had as to why there are so many craters on there was because things were falling into the sun and Mercury just got in the way. Anyway, but with the very large iron core, Mercury had somewhat of a magnetic field, and this would cause a shock effect to the solar wind that was coming off of the sun. And the solar wind was so powerful that even though there was a magnetic field, much of the solar wind was actually made it to the surface of the planet, where it acted like a sandblaster to actually blast the surface of Mercury into space. So Mercury really isn't a very nice place. The next probe that went out there was Messenger, and Messenger spent 10 years orbiting Mercury. Took lots and lots of pictures, and it discovered some really interesting things about Mercury. For one thing, even though its year is 88 days, 88 Earth days to take one trip around the sun, its day or its daily motion was actually 50 some odd days. So as a result, every 3 days on Mercury is equal to 2 Mercury years, which brings up all sorts of questions about how do you possibly design a calendar for that. But it did take some interesting pictures of the planet's surface. It found that the temperature in the shade was somewhere in the vicinity of about almost 300 degrees below 0 Fahrenheit, while in the sunlight, it was over 800 degrees. This would make Mercury the second hottest planet. Now, the interesting thing about Mercury was the fact that they, again, taking pictures of Mercury, they found that Mercury's day was rather interesting. As it went around the sun, as Mercury turned, you can see that it gets larger and smaller because the orbit of Mercury is somewhat elliptical, and there are times when it actually will go backwards in the sky and then go forwards again. So it gets larger and larger until at midday, and then it gets smaller and smaller, completing its daily rotation. So it would definitely make for an interesting school day on Mercury. Not really very nice at all. So taking a look at all the stuff on Mercury, it does look like the moon. There's a lot of craters on there. As a result, Mercury's uh, age, as far as its surface is concerned, is really quite old. Certainly, there's no air on Mercury. There's nothing to erode anything. So as a result, again, on one side of a shadow, you can be 200 degrees below zero, while the side in the sun will be 800 degrees. There's no atmosphere to distribute that energy. The other thing about Mercury is the fact that Mercury is shrinking. When Mercury was younger and its interior was molten, it was pushing out on the surface. And as it did that, Mercury was actually a little bit larger. Now that the core is cooling, things are contracting, and Mercury is actually getting smaller. Not quite like that, but we could actually see the fold lines on the surface of Mercury where Mercury is actually folding up. Another thing about Mercury that they discovered was the fact that there is water on Mercury. You know, there's water on something that's 800 degrees. You bet. In fact, it's ice water. And you're wondering, how in the world could that possibly happen? Well, there are parts of Mercury that are never exposed to the sun. And as a result, Mercury is, at least as far as the bottoms of those craters are concerned, is actually quite cold and a very good place to have water. So you have a hydrogen layer, and then below that, you'll have pure ice. And this brings up all sorts of interesting possibilities. If there's water on Mercury, could there be life? It really depends on who you talk to. According to some people, the life on Mercury would be more insect life. Now, Messenger, when it was orbiting Mercury, did spot some stuff that is a little bit, well, the people who are studying Mars right now so closely, they had a grand old time with Mercury. For one thing, they found that there was a door in the surface of Mercury, and there was all sorts of speculation on who was going in and out of that door. And they thought that maybe this guy was. And that was actually some type of a sculptured landmark on the surface of Mercury. So far, we really believe that I don't think there's any life on Mercury. There's no atmosphere. Any water that is on Mercury is either gaseous or ice. I don't think there's anything in between. But one thing that does bring up an interesting point is the fact that the possibility of life anywhere in our universe is a good idea. For one thing, if we were to take a look at the Orion Nebula is considered to be the birthplace of a lot of stars. There's stars being born all the time within the Orion Nebula. And taking a spectrum of that particular part in space, they have found all of the elements that are needed for life, and even some of the uh, materials uh, like water and sulfur dioxide and hydrogen sulfide, methanol. All these things are actually gases and chemicals that are within the Orion Nebula. So from all these chemicals here on the Earth, we have an amazing assortment of life. Everything from protozoa all the way up to mammals, reptiles, insects, just millions and millions of species. So it's possible that with this tremendous diversity of life, there might be something that could possibly survive even the surface of Mercury. And if something like that does, we have a name for that. We call them extremophiles. And if you look at a definition of an extremophile, it's an organism that would thrive under conditions that would kill everything else. And the term frequently refers to uh, bacteria and small cells, single cells, microbes. So these extremophiles, not only could they live in tremendous heat, but they might be able to live under no atmosphere. And in fact, they found some of these things that are quite amazing. For instance, we have the psychrophiles. These are organisms that are capable of growth and reproduction at temperatures that are minus 15 degrees Celsius. That's 5 degrees Fahrenheit. But when the temperature gets up to about 40 degrees, they actually fall apart. They literally disintegrate. So there's a form of worm that could only live in tremendous cold. Then there's the acidophiles. These are organisms that grow best in very acidic conditions. You have a fungus that can grow near a pH of 0. That is that's an acid that could virtually eat through anything. Then you'll have on the other side of the spectrum, you have the alkaphiles. Alkaphiles, these are organisms that would actually grow best in very alkali pH levels. So these would live great on soap, on Tide, all sorts of things that would just really not be very good for us. Then you have the endophiles. These are the organisms that live inside of rocks. Wow, it brings up all sorts of interesting possibilities if you're growing, because then you would actually have the rock protecting you. Reproduction inside a rock, according to this, would happen about maybe once per century. That would be frustrating. Anyway, and then another microbe or another extremophile might be the thermophiles. These are organisms that live in very hot temperatures. Somewhere, in basically approaching 200 degrees. And as you can see, we have a couple of things that look familiar. On the bottom, we have the tardigrade, and on top, we have the tube worms. And the tube worms are actually a sort of animal, believe it or not, that is an animal, and they actually live near volcanic vents. The temperature just outside these vents are several hundred degrees, and they are spewing hydrogen and methane. Now, there's no oxygen there, and you wonder, what in the world, how are these things living? Well, there is a fungus that lives inside the tube worm that will take the methane or the hydrogen and it'll eat it. And its waste product after eating the hydrogen and methane is oxygen. So these tube worms actually live on oxygen, but it's not oxygen they get from the free air. Then you have the hyperthermophiles, which really live in boiling water. And once again, you see the tardigrade there. You have the hypoliths, which live inside essentially translucent or spongy-like rocks. And then you have the pisophiles. And these are animals that live under extreme pressure, usually on the ocean floor or something along those lines. And once again, you have the tube worms and the tardigrades there. So you have one more extremophile, actually it's a couple more. You have the radio-resistant life forms. These are organisms that live in very high radiation. Could be ultraviolet or it could be nuclear. Tardigrades right there. And in 2007, researchers discovered a fungus at Chernobyl that uses the biological pigment that's called melanin, that's in our skin, to feed on radiation. When we're going to Mars, we'll talk about this because this could be an answer to a major problem. Then we have the xerophiles that live in no water. Tardigrades are once again right on top of the list because they could actually dehydrate themselves into a little ball and stay like that for 10 years or more. And then in order to get a tardigrade to come back out, all you have to do is add water and suddenly they're there and alive. So if you're looking for a life form that could live anywhere, probably the best one is the tardigrade because he is the king of survival. So I don't have a horn salute for that. So speaking of a super dry area with no water on it, the next planet is Venus. Venus has no water on it. It does have, when we look at it, it has an opaque cloud cover. And watching those clouds for the longest time, they thought that the rotation period of Venus was about 3 Earth weeks. And now we know that to be false because of the number of probes that we sent there. Us and the Russians. We sent all sorts of probes. Some of them actually landed on there. The most robust one that was sent to Venus was sent by the Russians, and it lasted a little bit less than 2 hours. So Venus is not a nice place to live. Some of the things that they discovered was the fact that, once again, the length of a day on Venus was tremendously long. and it went the wrong way. Our day is about 24 hours. The day on Venus is about, what would that be? About 50 some odd days. So it's not a very, very nice place to live. The atmosphere of Venus is electrically charged. Here on the Earth, we have, if you were actually measuring the field strength of our atmosphere, it would be about 2 volts. If you're measuring the field strength of Venus, it starts at about 10 volts. And as a result of that, electrical field, it actually caused the ions of the gases, mainly water and anything that could resemble water, to become ionized and be repelled by the planet. So again, there's no water on Venus. And while the temperatures are similar to pizza makers, there we go. Pizza ovens have a temperature of about 900 degrees. Venus has a temperature of about 864 degrees or a little more. But because of the 200, or actually 100 to 200 mile per hour winds, rather, if Pizza Hut set up their restaurant on Venus, you can have a pizza heated and ready to eat in 7 seconds. We should tell Pizza Hut about that. I think I'm tired of waiting anyway. But so because of the fact that it's one of those air stoves that move the air around, you can actually cook a pizza in 7 seconds. The thing is, though, it doesn't have any air there. I mean, at least anything that we can breathe. There's mainly carbon dioxide on Venus. Again, the temperature is around 900 degrees. Venus is the hottest planet in our solar system. And so it's not really a very nice planet. Plus the fact that the air on Venus is actually about almost 70 times more dense than the air on the Earth, which can cause some problems. For one thing, it would be awfully hard to breathe. The other part of trying to breathe this is the fact that the air pressure is about 90 times that of the Earth. So not only would you be trying to breathe in jello into your lungs, but you wouldn't be able to get your lungs to work simply because the pressure is too high. So on Venus, again, the Earth, the density is about 1 kilogram per cubic meter. And as you can see, it takes things and blows them away. Blows a car, right? I mean, just blows everything. On Venus, if you had that wind blowing about 200 miles an hour with something that had the density of a little bit less than jello, you can use it to sandblast. At 100 kilograms per cubic meter, you can actually use a stream of water to cut metal. So yeah, Venus is not a nice place when it gets into that. If you built a house on Venus and just let it survive, I don't think it would survive 3 seconds. It would look something like that, just gone. But if you were on Venus and you were trying to find the sun, it would be something like this. And as you can see, the sun would just be a very, very minor bright spot in the sky. with dust and dirt and rocks being blown around at something along the lines of about 200 miles an hour. So Venus is definitely not a nice place to live. And it's getting worse. In the 6 or 8 years, a little bit more, that we have been keeping track of the weather on Venus, they found that the wind speed is actually increasing. So not only is it hot, dry, and really windy, but it's getting even more windy on Venus. So the weather on Venus, I guess you can say, it's extremely hot. Air pressure is extremely high. Strong winds are blowing things at 200 plus miles an hour. And then to top it off, sometimes it rains on Venus, but it doesn't rain water. It rains sulfuric acid. So then there's also lightning on Venus, but the lightning doesn't come from clouds. It actually comes from the charged particles in the air that's being sped around so much. And then you have volcanic eruptions that will complete the circuit in the very charged atmosphere, and you'll get lightning bolts that will absolutely floor you. It's way more than what you would get if you was just cloud to cloud or cloud to ground. So Venus really isn't a very nice place. They have found that Venus is a very active place as far as volcanoes are concerned. Again, there's these volcanoes, those are actually volcanoes. They are not craters. And they are, as a result, the surface of Venus is constantly changing. You can see that there's virtually no craters on Venus, at least craters made by anything that came through the atmosphere. The atmosphere would burn up anything that tried to go through it. But these volcanoes are actually caused by the fact that, again, the surface of Venus is constantly changing. And you can see that if you're taking a look at the age of Venus, you can see that Venus and the Earth are relatively new, while Mercury, the Moon, and Mars are relatively old. So Venus is a fairly new surface. And what's happening on Venus is just like what happened as far as the Hawaiian Islands are concerned. Below the surface of Venus, within the mantle, there is a magma pool. And as the tectonic plate moves over this magma pool, it'll actually push through and form a volcano. So as a result, we'll have a string of volcanoes like there are a string of Hawaiian Islands. But with the atmosphere blowing so much, with the sulfuric acid, with the tremendous heat and friction, there are no peaks on these rocks. These rocks have been sand blown flat by the tremendous heat and wind that Venus has. And again, these were taken by the Russian probes. And again, the longest one lasted just under 2 hours. The fault lines on Venus are quite pronounced. And so you can see that these are actually called spider lines. And I think you can see why. So if you try to live on Venus, you would find that the gravity might be the same, but the length of day is 243 days compared to our 1 day, and it's going the wrong way. Temperatures, Venus is the hottest planet in our solar system. The last Venus probe took a close look at the weather, and believe it or not, the weather is very similar, at least as far as how the winds move on Venus. It's very similar to the Earth. We have something called a Hadley cell, where the temperature, actually the atmosphere, rises above the equator. And as a result, it will move toward the poles where it cools slightly and then comes back down. And then it's kind of a cycle where it comes down at the poles, travels over the surface of the planet, and then rises above the equator. Now, with our planet, with the Hadley cell, is augmented by something known, well, it's the centripetal force. It's something called the Coriolis effect, which will actually break up this Hadley cell. On Venus, there's hardly any movement. As a result, almost all of the air is moved by the unequal heating of the gases. But even with this uneven heating, the atmosphere will actually spin at somewhere in the vicinity of about 200 to 300 miles per hour, and will actually whip around the planet in 96 hours. So I guess you can say that the weather on Venus is similar to the weather on the Earth. And some surprising things about Venus is the fact that I haven't said anything about the greenhouse gases, but we will shortly. But Venus is an interesting planet in the fact that you wonder about, could anything at all possibly live on it? And once again, Venus showed how close it is as far as weather is concerned, how close it is to the Earth as far as how the weather moves across the planet. On August 10th of this year, Iowa experienced something called a derecho, or derecho, depending if you're which side of the Atlantic you're on. And this was a thunderstorm line that went across the state. This was actually a picture of the radar taken every hour. And you can see it's a tremendous storm covering about, about 200 miles wide. I'm sorry, long, about 50 miles wide. And it made it across the state in less than 4 hours. It packed winds of up to 140 miles an hour. And even the day after, as you can see just below, it went through Illinois, and it took a long time for that to dissipate. Well, about 2 weeks before this, they actually discovered the same thing on Venus. Actually, this was about 2 years, no, a couple of years before. They actually found a derecho on Venus. And this was moving at 200 miles an hour. It was about, it extended, the wave went across the planet about 4,600 miles. And it was made out of acidic gas. Well, I'm glad ours wasn't made out of acidic gas. But this was virtually the same thing. Now on Earth, it's called a derecho. On Venus, it's called an atmospheric disturbance. So I'm not quite sure where they got derecho from. So could life actually live in this, I want to say, a hellhole? Well, according to some authors, it did. We have the golden Amazons of Venus. We have the gods of Venus. Have you noticed that they all seem to be scantily clad women? I mean, I don't understand that. They even have the thing of Venus, again, capturing a woman. Now, according to NASA, really the best way we can live on Venus is above the clouds of sulfuric acid. And that's a strong possibility. If there's going to be anything landing on the planet, it better be made out of something that's semi-impervious to acid, or certainly 200-mile-an-hour winds and 900-degree temperatures. So what is the possibility of life on Venus? Well, believe it or not, there is a belief that when our solar system formed, Venus was well within the habitable zone. And for approximately 4 billion of Earth years, it was actually a good place to have life. When our solar system started, when the sun was first formed, the sun was about 15% dimmer and cooler than it is now. So as a result, our habitable zone actually straddled Venus very well. Venus was well within the habitable zone and possibly a good place to, for life to thrive. But as time went on and our sun aged, we found that our sun actually increased in brightness and in heat. And as a result, it got got hotter, and our habitable zone moved outward. As you can see, the Earth is now in the middle of it with Mars skirting it. So it's possible that Venus may have been well within our habitable zone and may have actually had life around it. According to a lot of astronomers, Venus's present predicament is actually relatively new, only about 700 million years. So for the first 3.5 billion years of its existence, it was actually a good place to live, good neighborhood. But in the last 700 million years, something happened. There was a tremendous outgassing of carbon dioxide, possibly carbon dioxide that was infused in the rocks. And this carbon dioxide caused a runaway greenhouse effect, which caused a tremendous amount of heat. And as a result, Venus lost all of its water and also lost its ability to hold life, maybe. So Venus went from this to some kind of outgassing to a total cloud cover. A radar view of Venus shows its modeled surface, and then it has these dark areas. And these dark areas seem to change its shape over time. Could those dark areas be some type of a life form, a fungus of some time that actually spreads, actually expands and contracts over the surface? One of the interesting discoveries that was made happened in the last about 2 weeks, and that was the discovery of phosphine. Phosphine is a very toxic, smelly, smells like dead fish, gas that is usually produced by something that's living. At least that's the way chemists see phosphine. Now, maybe there's other ways of making it, but they're taking a very, very close look at this, and they're hoping somebody else discovers this as well. Somebody else will discover that there's phosphine on the planet. If there is, and the only way to make it is by something that's living, then maybe it is those dark areas that are changing their shape. Just don't know what they are. Right now, as we are sitting here, there is a probe on the way to Venus. It was sent up by the European Space Agency, and its first flyby of Venus will happen on October 16th, 2020, just about a month from now. And we're hoping to learn an awful lot more about Venus. So, we'll find out. We'll find out hopefully more about that phosphine. Okay, so that's Mercury and Venus. Next week, the Earth and Mars, the present and future home of mankind. And I know you've never seen Earth and Mars like that.